Hi everyone, my name is Marco from LightObject. Today the topic is cutting precision. I believe most of you have experience of cutting issue like accuracy issue. For example, when you try to cut something like a 100 by 50 there's about 2 or 3 offset. So how do you fix it? And today I'm going to show you the steps to configure the DSP controller card and fix the offset issue. Okay, before I start, I need to show you guys a couple of things that will affect the precision of cutting. First thing is the microstepping driver. This driver determines how precise for each step. In general, we set 3,200 or above for the laser machine, and I will show you or explain a little bit more later. The second thing is the motor. There are two different kind of stepping motor in general. One is a two-phase, the other one is three-phase motor. For two-phase motor, each single step is 1.8 degree, but there's another one is 0.9 degree. So each pulse sent to the motor, it turns 1.8 degree. All right, and the quality of the stepping motor is very significant. Another thing that will affect the precision is the belt, and I think this is most likely happen to the offset in general. All right, because the belt is when you use it for a certain time, it depends how often you use. It could be 1 year, it could be 2 years. We don't know. Again, it all depends how heavy you use your laser machine. The belt is made up of some rubber and some tissue, a special fiber built into it. It's pretty strong when it's brand new, but after a certain time, then you lost the elastic, and that's why we need to use the software that come with the DSP controller card to make calibration, and this is what we are going to do today. Okay, I'm going to make an example by using a machine here. I'm going to try to cut a square 50 by 50 and then measure the actual size of the cut. Then I will show you how to calibrate. Let's see how good of this machine. All right. Okay, to reset the parameter for the we open the LaserSoft software, and then we click the system setting. And from this screen, you see that it shows x-axis, y-axis, z-axis, and u-axis. All right. So we have to do x and y. So let's do x first. There's a button next to it. So we click this one. The expect value is 50. That's what we want to be. But the actual was 46.5. So we put down 46.5 here and click OK. Then it will come up a new number for us. Same thing to the y. So we click the button and we put down 50, and then the actual value that we got, actual cut, is 50.3. Once you did that, the system will recalibrate the for the machine, and then you're ready to go. And then we close it. Okay, the file has been uploaded to the DSP controller card and it's ready. So hit the origin and click start. All right. So I'm going to use a calibrator to measure it. This is the X, this is the Y. To You can tell this is way off. Suppose 50, but now it's showing 46.5 on X. And then for the Y, this is 52.4. So how do I correct it? Okay, so I got the actual cut. The X was 46.5 and the Y was 52.3. So after I update the parameter, I'm going to send the job to cut again. Now see how it goes. Ready? And go. It looks much better. Let me take it out and measure. And we need a marking. We put an X here, we put a Y, so we don't get confused. So let's measure it again. Oh, it's not right. Oh, let me see. Oh, sorry, guys. I need to zero first. So see that 50, perfect. And look at the Y, touch it and touch it. 49.93, which is pretty close. Okay. I have explained in the previously that a motor in the motor driver play some significance to the precision on your cut as well too. Let me explain the relationship between the motor and the driver. In general, let me take the two-phase motor as an example. If you may not feel it, but for stepping motor, when you turn it, it feels like a step by step. You want like a step by step. When I turn it, I can feel it. It's like a step on each movement. So for a two-phase motor, in general, this is 1.8 degree per step. That's take about 200 pounds in order for the gear to make a complete 360 degree revolution. Let's say if it starts from over here, it takes 200 pound step like this to complete one revolution. For the motor to turn 1.8 degree, do you think this is good enough for being used in a laser machine? I will tell you that it's no. Why? Let me do a simple math here. We have a gear, and when we measure the radius, this is about, let's see, center 8 millimeter. Let's say roughly. The R equivalent to 8 millimeter. So for one gear like this one, the R is 8 mm. So there's the circumference for the wheel by formula is 2 pi times R, which is 2 times 3.1416 times 8 mm. All right. So let's do a calculation. 2 times 3.1416 times 8. So the circumference for this wheel is 50.28 mm. So 1 pulse, how much you move per pulse? Remember, this is 1.8 degree per pulse, right? So we need to calculate how much distance it travels. So how do we do it? 360 degree, 1.8 degree on top, radians. So this is like 1.6 over 360 times the pi, and times 2. You see 2 pi, I'm sorry, a little bit confused here. 1.8 degree, 2 pi r, yeah, and then times r. So 1.8 degree divided by 360 times 3.1416 times 2 times 8. So this is about 2.5
mm. What is this number? What's the 0.25 here? 0.25 means when this motor get one pulse from the controller card, one pulse, it turn 1.8 degree and it will travel 0.25 mm distance. Is it good enough for a laser machine? Definitely not. The reason is for laser dot, by looking at the dot from our naked eyes, we can estimate this is like a 0.1 mm in diameter, but actually the actual size, because the beam is not flat, the beam is like a cone shape. So I can estimate that the beam spot for the pulse, for the laser pulse is roughly 0.2 to 0.02 to 0.3 mm. So 0.25 movement is way too off to make it good for laser engraving or cutting. You will end up like when you try to engrave something, instead of a continuous line like this, it will come up like a dot. So how do we fix it? Well, this is what a motor driver is supposed to do. If you look at the table here, there's a chart. It shows you how many steps required to make a full revolution. So how many micro step do we need it? Let's do a math here. 0.03. Let's say we take 0.03 and compared to this 0.25. That means we need 10 times finer in order to make the laser to function properly. Okay, for a two-phase motor, it take it take 200 steps to complete one revolution because each pulse take 1.8 degree. But by using the calculation I did before, each pulse, the wheel will travel 0.25 mm distance. But the laser dot, by assumption, the size of the dot is 0.02 mm. Alright? So, is it good enough for having the motor at 200 steps to do the laser job? It is not, because as you can tell, the diameter of the dot is 0.02 and the movement is 0.25, which is about more than 10 times wider. So it will end up like a dot. When you try to cut something, it will come up like a dot. So how do we fix it? Well, it comes to a motor driver. If you look at the chart here, it will show you the micro stepping on each setting. 200 is by default, means there's no modification happen. The motor will run at 200 pulse. Well, but as we just said that 200 is not good enough, right? So there's a setting for 400, 500, all the way down to 12,800. So which one should we go, or which is the minimum should we go? All right. By looking at this number, we can say this is a roughly, 12 times. We need 12 times more detail, more finer in order to make it work. So 200 times 12, that means 2,400, or roughly, okay? In order for the laser machine to do the job right and well, so we need minimum 2,400. For a laser machine, there are two different setups. Some of laser machine, they don't have the reduction gear. Some they do. For mid-size laser machine, they used to have a reduction gear. Let me show you what is a reduction gear. Okay, this is the reduction gear for the X. If you look at those, this is the stepping motor, and this is the gear on the motor, and this is another gear on the gantry. The T ratio is 1:2. So if this one travel, let's say 10 mm, then this gear or the belt over here will travel only 5 mm, half of the distance it travel. Okay, this is another gantry system. If you look at here, it doesn't have the 1:2 reduction gear installed. Instead, this is like a direct drive. See the motor, get a gear here, and you hook up another return gear, and then the laser cartridges run on the belt direct. So the ratio is 1:1. But if you look at the Y, we still have a 1:1 reduction gear. The reason is the gantry over here is a little bit heavier. That's why we want to use 1:2 reduction gear. The advantage of having the reduction gear is to increase the drag power or the torque, so you can carry heavy stuff to move better. But for this one, we don't need it because the laser head is small and with lightweight, and we want it to travel fast than the big machine. That's why we don't use reduction gear, and the laser head will travel in double speed of regular laser machine. Now back to here, as I said, we need 2400 in order to get a decent job. We don't want to get something smaller than 2400, right? But this is for direct drive. If for the machine with I would say 1:2 reduction gear installed. So this 2400 is going to be like 4800 because you're slowing down the speed, but the distance also slowing down by 50%. So it's the 2400 on a direct drive is equivalent to 4400. Okay, let's go back to our calculation sheet. Remember that we need 10 times final setting on microstepping, which is equivalent to 2400, right? And this is the minimum required for the laser machine to perform a job. And this is the minimum. Again, this is the minimum required. But this is for direct drive though, because on this machine, there's a 1:2 reduction gear. What does it mean? It means the speed will drop by half. But also the distance or the precision will also improve by half too. So if you set the microstepping on this motor driver, that means if you divide it by 1200, is the minimum required on the motor driver for the machine to work properly. But of course, we don't want to go for the lower, because remember 1200 is the minimum. In general, we choose 4000 or 5000. Why? Because sometimes when we do high detail graphic engraving, we require 0.01 mm precision per dot. That's why we want to go higher, and that's why we choose 4000 to 5000. Some of machine they can sustain such high speed. So if you set it for 4000 or 5000, the motor may stall or skip. In that case, you have to drop it down to 3200 or even 1600. All right. But for laser machine with direct drive, I don't recommend to use 1600 because it's really, I mean, the result from the engraving is kind of a little bit out of detail. So I would highly recommend you go from 3200, starting from 3200 and up, sometimes up to 6400. Okay. But anything go over 6400, it's not significant. You won't gain too much detail. Or some people ask me, hey, if I set up the microstepping to higher, like 6,400 or what else? Let me see. Maybe 10,000 or 12,800. Does it help a lot? I can tell you that it won't help much though. However, for rotary is a little bit different because rotary is a direct drive and it doesn't, how to say, for the rotary to perform well, you want to go by at least 6,400, or in general, they set it to 12,800. But I will usually go by 6,400. There's another reason I don't want to go for 12,800. It's about the torque, because higher stepping rate means, find number here. It's a little bit confused, okay? The higher the number, the smaller the step. The smaller the step, the less torque it is. So if your laser head or if your system is a little bit old, you get some resistance on it. If you set the microstepping too fine or too high on that value, the system will skip or stall. All right. So we want to going down, set it down to 5,000, 4,000. So you kind of balance the torque and the speed. For power Z table, we don't want to go 4,000 or 5,000, something like those, because for Z table, it's kind of heavy, right? You want to get, torque as much you can. And in general, we use 1,600 for Z table because lower the smaller the number of the microstepping, the higher torque you can output from a motor driver. This is all for today, and I hope you guys can learn something. If you have any question, either email us or call us. We are here to help. Thank you for watching.